Driving down the highway, we never stop to think what makes it possible for us to be where we are. The guide rails that keep us safe from oncoming traffic, the signs above us that guide us in traffic, or the very vehicles we're sitting on. When we're at home, on our trampolines, enjoying ourselves, when we see a baby walking around on a stroller, what supports them? What is it that modern things have in common that allows them to be what it is that they are? Roll forming is a continuous bending operation in which a long strip of sheet metal, typically coiled steel, is passed through sets of rolls mounted on consecutive stands, each set performing only an incremental part of the bend until the desired cross-sectional profile is obtained. Roll forming is widely used in industry to create parts that are long and have intricate and complex geometries. The invention of the rolling mill is attributed to Leonardo da Vinci. Earliest rolling mills were slitting mills, which were introduced from what is now Belgium to England in 1590. These passed flat bars between rollers to form a plate of iron, which was then passed between grooved rolls to produce rods of iron. However, the first laboratory rolling experiments only took place in 1670, and rolling has never been the same since. Modern rolling practices can be attributed to the pioneering efforts of Henry Cort. In 1783, a patent was issued to Henry Cort for his use of the grooved rollers for rolling iron bars. With this new design, mills were able to produce 15 times the output per day than that of traditional hammers. Although Cort was not the first to use groove rollers, he was the first to combine the use of many of the best features of various iron making and shaping processes known at the time, thus making writers call him the father of modern rolling. The first rail rolling mill was only established in the 1820s by a man known as John Birkinshaw. With this advancement in technology, machines grew bigger and bigger very quickly. Flower pattern is the most commonly used form of roll forming in modern manufacturing. The idea is very simple. Small, incremental bends are applied to materials successively until the final shape is obtained. The order and magnitude of these bends is crucial in determining both surface finish and accuracy of the final part. In modern manufacturing, finite element analysis and roll forming go hand in hand. FEA simulations are used to determine whether certain patterns are feasible and whether or not successive rolls are either too aggressive or not aggressive enough. As can be seen here, if successive rolls are not well designed, large stresses are placed on the material, deforming it in ways that are not desirable and can damage both part and machinery alike. Well-designed rollers generate stresses only when necessary and ensure that the surface finish is exceptional and that the part fits within spec, time, and time again. This may require more rollers with very particular shapes and sizes, but it is much cheaper in the long run and creates a much better final product. Remember the guide rails from the beginning of the video? Let's have a look at how they are actually manufactured. Something most people are unaware of is that most thin-walled circular tubing is made using roll forming methods. This is because roll forming is much cheaper than punching or stamping or other equivalents and uses far less material. It also allows you to make tubes and pipe of any length and make them repeatedly and quickly. Extrusion also allows for parts to be made of any length and dimension. But unlike roll forming, surface finish and part tolerance are significantly compromised. Roll forming still remains the cheapest and fastest method to make hollow piping, gutters, vehicle guide rails, so on and so forth. This is a video of typical mass production thin-walled hollow piping. Roll forming can be used in conjunction with other modern manufacturing practices such as spark and arc welding to create complete, finished, and high-quality products. Roll forming is done at moderate to high temperatures, but cold rolling exists for more malleable metals. Once an object has been rolled, it is typically cut to length by some sort of bandsaw or slitting tool. Foam rolling has a wide range of uses, which include but are not limited to embroidery, threading, cutting, and shaping. Foam rolling has completely changed modern manufacturing, and I hope from this video you are able to see that not only is it useful, but it is a method of production that is here to stay. Thank you for watching.